All right, guys, welcome back. Today, I'm going to try something I haven't tried before. We're going to try and do the volume of prisms and pyramids at the same time. Normally, I break it up and do prisms one day, pyramids the next, but the formulas are close enough, and this, yes, we actually get a formula this time. It's not like surface area, but we need to be careful that we know what shape we're dealing with. So, first of all, what is volume? When we're talking about the volume of a three-dimensional shape, we're talking about how much can it hold? How much will fit on the inside of that shape? How much space is there inside the shape? And that's going to look different because if I have a rectangular prism like this is kind of like, I don't know, a box of cereal. So the volume of that box of cereal is how much cereal will fit in the box. Whereas something like a water bottle is just a 3D shape. And the question might be, what's the volume of the water bottle? How much water, how much volume will that three-dimensional shape hold? And the way that we do that, we have a formula, but that takes a little bit of logic, and that's what I want to walk you through really quick is the logic behind the formula. I'm not going to go into a lot of detail, but we're going to talk about kind of why that formula is what it is. So for right now, ignore big B right here, and I just want you to look at this shape. When I look at this shape, the first thing I see is I've got this rectangle on the bottom. And my prism, this rectangular prism, is made up of a whole bunch of those rectangles stacked on top of each other. It's kind of like if I were to take this centimeter cube, and I've got 1 centimeter cube, and then I take another centimeter cube, and I stack it on top, and I take another centimeter cube, and I stack it on top, and they're the same cube, they're the same shape, and I just keep stacking them on top of each other. If I do that a whole bunch of times, eventually I get this three-dimensional shape. It's got 10 of those cubes stacked on top of each other, which is all this shape is. We've just got a bunch of these rectangles, a bunch of saltine crackers stacked on top of each other. And the way the formula works is to figure out the space on the inside. The first thing that we want to figure out is how much space does one of these little rectangles take? And then we want to figure out how many of those rectangles are stacked on top of each other. So the formula, I'm going to write it down, and then we're going to talk about what the different pieces mean. So the formula for the volume of any prism is big B multiplied by the height equals volume. Big B multiplied by height equals volume. Now, big B, what is big B? That's kind of the important one for this one. Now, remember, these are prisms, not pyramids. These are just for prisms, our saltine crackers, okay? Big B represents the area of the base. Big B is the area of the base of the shape. Or in other words, it's the area of the shape of the saltine, if you want to write that down to remember it, okay? The area of the base. So if I look at this example, my base is a rectangle, and it's 3 inches wide and 2 inches tall. So 3 times 2 gives me 6. The area, my big B, the area of my bottom shape that keeps getting stacked up is 6 inches. That's the area of this shape. Now, height in my formula represents how tall my shape is, or in other words, how many of those are stacked on top of each other. When I did the centimeter cubes, how many of these centimeter cubes are stacked on top of themselves? How many saltine crackers are stacked on top of themselves? So that's my height. So that's going to be, H stands for the height of the shape. And again, in parentheses, if you want to put how many saltines. How many saltines are stacked on top of each other? So I take my big B and I multiply it by my height. Big B, I've got to do a little bit of work, the area of the base. The area of my base is 6. That's how much space this rectangle takes up. Now the height of this shape is 6 inches. So that means that there are 6 of these stacked on top of each other. There's 6 inches worth of those areas, those rectangles, stacked on top. There's, in this case, that's like 6 centimeter cubes being stacked on top of each other, or 6 saltines. So I take big B times h, the height of my object, which is 6 for my height, or my big base, and then h, my height of the object, is 6. So 6 times 6 equals 36 inches cubed, because we're in 3 dimensions now. Our volume is 3-dimensional. We're not doing area anymore. It's 3 dimensions, so 36 inches cubed. That gives me the volume of this prism. Okay, now let's look at this prism, because it's a little bit different because it's tipped over. Right now, this rectangle's on the bottom, but that's not the shape that keeps getting stacked up. If I kept stacking up that rectangle, I would have a box of graham crackers, but I don't. I've got this triangle shape. And so the shape that keeps getting stacked is this triangle right here. That's the shape that keeps getting stacked. So I want to know, what is the area of that shape? What is my big B? What's the base area? Well, this is a triangle, so I need the length, which is 10. The height of the triangle is 12, these two sides. So 10 times 12 is 120. So 10 times 12. But it's a triangle, so I need to divide that by 2. I'm looking for the area of just this rectangle, or this triangle. Not both of them, just this one right here. So 12 times 10 divided by 2. 12 times 10 is 120. Divided by 2 is 60. So my area of this saltine cracker that's shaped like a triangle is 60. That's my big B. Now my H, the height of my saltine crackers, if I were to stand this up, how many of those are stacked on top of each other? It says there's 16 of those tall. So that's like there being 16 stacked up. So H equals 16. So let's plug that into my formula. Big base, 60, times 16, my height. And we'll go ahead and show you that right here. 60 times 16 gives me 960. So 960, my units are meters, meters cubed. So I take the area of the bottom, how big is the bottom, and how many of those are stacked on top of each other. And I do that over and over again. So this shape right here is a little bit different because this one, it looks like there's an octagon on the bottom that keeps getting stacked on top of itself. But we don't really have a formula for the area of an octagon, but look right here. It gives me the area of that octagon. It says that big B, this octagon, is 80 meters squared. So I already have big B. I just need to figure out how many of those octagons are stacked up. And that's this number right here. How tall is that shape? So my height is 11. So I just plug that in my formula. Big B is 80, and there's 11 of those stacked on top of each other. So 80 times 11 is 880 meters cubed. 880 meters cubed. That gives me the area, or the volume, of this three-dimensional shape. It would fit 880 cubic meters of water or goldfish or dog hair. I don't know, whatever it is that you're putting in it, it would fit 880 cubic meters of that shape. And we'll talk a little bit more about that cubic meter idea another day. Okay. Pyramids. Again, this is new to me because I don't usually do this on the same day, but the formula for a pyramid is almost the exact same. It's still big B. You find the area of the base, and we multiply that by the height of our shape. But the problem is if I take big B times H, that just takes this big square, big B, and stacks it on top of itself H times. But this isn't a bunch of squares stacked on top of each other. If you look at the pyramid, the squares get smaller and smaller as you stack them on top of each other. They get littler and littler until they're just a point at the top. So we can't just do base times height because our base, our big B, gets smaller as it gets taller. And we'll go through the proof of this formula another day. But for now, it's kind of like a triangle. In 2 dimensions, a triangle, we do the length times the height and we divide it by 2 because it's 2-dimensional and we turn it into a rectangle. Well, this shape, if I do base times height, I turn it into this shape. But obviously there's a difference. There's a whole bunch of space that isn't being used like it is in this picture. So I have to do base times height and then divide it by 3. And the best I can tell you to remember that is when it's a triangle in 2 dimensions, we divide by 2. If it's a triangle in 3 dimensions, like a pyramid, then we have to divide by 3. So base times height divided by 3 equals the volume of this shape. Other than that, it's exactly the same. I look for the big B, so big B first. What is the area of my base? And the nice thing about this year is your pyramids are always going to have a square base. So my big base is just 8 across and 8 up. So 8 times 8 is 64. That's the area. That's my big B right there. 64 is big B. So how many of those big B's get stacked on top of each other? We need to be a little bit careful because this is where this weird line floating in the middle of the pyramid matters. We want to know how tall the pyramid is, not how tall the triangle on the side of the pyramid is. We want the height of the pyramid. So I look at this line that's in the middle of the pyramid from the center and it goes up. This little arrow right here tells me that my pyramid is 9 tall. So my H, my height, is 9. So my volume is going to equal my big B, 64, times my height, which is 9. So 64 times 9. Now 64 times 10 is 640. I've got a minus 64, so that's going to be 576 maybe? Let's try it out. 64 times 9, 576. So 576, but we need to make one more change because this isn't a bunch of squares stacked up. This is a pyramid. So 64 times 9 divided by 3. It's a pyramid. So 576 divided by 3. So that 576, let's divide it by 3, and we get 192. So the volume of this shape would be 192 centimeters cubed. So the formulas are almost the same, but this one we have to divide by 3 because it's a pyramid, not a prism. It gets skinnier as it gets closer to the top. So one more example, and then I'll let you do the practice on, or try some problems on your own. It says to find the volume of a pyramid that has a area, the base's area is 54 and the height is 7. So big B times height divided by 3 is 54 right here, times height, which is 7, divided by 3. So 54 times 7 divided by 3, and I get 126 feet cubed. That means there's 126 little cubes, kind of like these little cubes, except they're feet cubes. So it's 1 foot wide, 1 foot tall, 1 foot thick. All right. Okay, some problems to try on your own. Down here, you've got 5 of them. You've got a prism right here. Be really careful what shape is getting stacked up over and over and over again. It's kind of nice because it gives you the base of that one. Again, right here, be careful what shape is getting stacked over and over and over again. Then you've got a story problem. It gives you some of the information about the shape. See if you can figure it out. Then you have a pyramid. Be careful that you divide by 3. And then you have another story problem with a pyramid in it. Be careful to divide by 3. Let's try this out. I'm hoping that you guys can handle doing both of these shapes in the same day. So do those 5 problems. Come show me your work. Show me that you're done. And I'll give you the practice for the day.